Scatter diagram. Scatter graph is a tool that we use to display two sets of data to see if there is a correlation or connection between them. Example: the number of umbrellas sold and the amount of rainfall on 8 days is shown on the scatter graph and in the table. We can also draw a line of best fit on our scatter plot. It should have roughly the same number of points above and below it. The line of best fit gives us a clear outline of the relationship between the two variables, and it gives us a tool to make predictions about future data points. The graph shows that there is a correlation between the number of umbrellas sold and the amount of rainfall. On days with higher rainfall, there were a larger number of umbrellas sold. There are three types of scatter diagram based on the slope of trend of the data points. Positive correlation: as one variable increases, the other one also increases, then the best fit line slopes upwards. Negative correlation: as one variable increases, the other decreases, then the best fit line slopes downwards. No correlation: a scatter plot in which the points do not have a linear trend, either positive or negative. It means there is no connection between the two variables. Scatter diagrams can be divided into according to the type of correlation. Strong correlation: all the points are very closely aligned, either in negative or positive correlation. Weak correlation: the points are quite spread out and not clearly in line, either in negative or positive correlation. For each of the scatter graphs below, state whether or not there is correlation, and if so, state the strength and type of that correlation. No correlation. Strong negative correlation. Weak negative correlation. Strong positive correlation. Weak positive correlation. Interpolation and extrapolation. The process of the predictions within the range of our data is known an interpolation and is generally quite reliable. Because the line of the best fit gives us a clear outline of the relationship between the two variables, and it gives us a tool to make predictions about data points. For example, let's take the graph that shows a correlation between the number of umbrellas sold and the amount of rainfall. How many umbrellas would be sold if there was 40.4 millimeters of rainfall? We draw a vertical line up from 4.4 millimeters until we hit the line of best fit. Then we draw a horizontal line across from that point to the axis. It touches that axis at 32 umbrellas. The process of the predictions outside of the range of our data is known as extrapolation, and is risky because we don't know how the pattern of the data might change outside that range. How many umbrellas would be sold if there was 7.5 millimeters of rainfall? We draw a vertical line up from 7.5 millimeters until we hit the line of the best fit. Then we draw a horizontal line across from that point to the axis. It touches that axis at 56 umbrellas. Careful, extrapolation can give misleading results because the pattern outside the range of the data might change.